This is a very important topic because once you are equipped with this, you can modify equations so that we can solve for different variables from a single equation. Now, this is more like a tool or method that you can remember when working with equations. For example, if you're working with the simple interest or compound interest formulae and you need to solve for different variables, sometimes you can just isolate a specific variable and just go directly to the answer. Right, so there's vast applications to literal equations, but as we progress through the course, you'll see some of the things that I mentioned here will actually expand your mind a bit. Our aim is to make one of the variables the subject of the formula. This is the same as isolating the variable. You're simply following the rules I discussed under the topic order of operations. As a reminder, I said that when you're solving for an equation, follow the BODMAS or PEMDAS rule in reverse. Right? So let's consider a few practical examples. Let's say we are given a temperature in Fahrenheit and you require the temperature in Celsius. However, the formula you remember is the one converting from Celsius to Fahrenheit. In this case, you would have to make Celsius the subject of the formula. So let's say that this is the formula you remember. Now, if you want Celsius and you're given the Fahrenheit temperature, so you can put in the Fahrenheit temperature and solve for Celsius. However, the more systematic approach would be to make Celsius subject of the formula and just input the Fahrenheit temperature. Now, let's say that you are required to convert 50 Fahrenheit temperatures to Celsius. This will be a more practical option, as opposed to inputting those 50 different Fahrenheit temperatures and making Celsius the subject of the formula 50 times. Understood? So this is more like a practical way of remembering why we do it. So what would we do first? We need to isolate degree Celsius. So first we'll subtract by 32 on both sides. So degrees Fahrenheit minus 32 is equal to degrees Celsius times 9 over 5. Then we multiply by 5 over 9 on both sides. So therefore we'll have degrees Celsius is equal to 5 over 9 in brackets degrees Fahrenheit minus 32. And that's how you convert there. Very, very simple idea. These are some of the rules that I talk about when working with literal equations. So let me explain each rule that you need to remember, and I'll put an example to it for you to understand what I am saying. If we have fractions multiplied by the LCD, so let's say that we're given a over b plus c over b is equal to 2, and we're required to make a the subject of the formula. Then just multiply by the LCD on both sides to make a the subject of the formula. So if I multiply by b on both sides, watch here. If I multiply this side here by b, and if I multiply by b on this side, then I'll have a plus c is equal to 2b. And therefore a is equal to 2b minus c. So can you see how by multiplying by the LCD on both sides, we get rid of the denominator and we left with the numerator? Because what do we want? We want a value that's in the numerator to be the subject of the formula. So therefore we need to get rid of the fraction. How do we get rid of the fraction? By multiplying by the LCD. Right, let's say that we're given a over z over 2 minus b, and we're required to make b the subject of the formula. Multiply by the denominator again, multiply by the LCD. So therefore we'll have 2 minus b, right, multiplied by a is equal to z. Therefore 2a minus ab is equal to z. We're required to solve for b. Therefore minus ab is equal to z minus 2a. And therefore b is equal to z minus 2a over minus a. That's how you solve for that. Right, very simple. So when you're given a fraction, to get rid of the fraction, you can multiply by the LCD. Or yeah, you could just simply say cross multiply. Because I'll put a over 1, I'll say that times that times that. Right, and then we can solve. Right, the next one. You can factorize to isolate a variable. So what would that mean? Let's say that we have v minus uv is equal to ab. And they say solve for v. They're saying solve for v and v is in two terms. In order for me to isolate the v, I need to factorize it. I need to take it out from this term and that term, since it's common to both terms. So now it'll be v into 1 minus u is equal to ab. That's where the factorization rule comes in. So therefore v is equal to ab over 1 minus u. Again, let me say this again. The only time you will utilize factorization, because we used it extensively, but the question is, when do you utilize it? The only time that you will utilize factorization is when you see a plus or minus sign. We learned factorization. We know when to use the different techniques because according to the number of terms in the expression, you will utilize a different technique. But another rule that you must consider is that since we're focusing on the word terms, what separates terms? Plus and minus signs. So that's the only time you can utilize factorization. So keep this at the back of your mind. Keep that at the back of your mind. Okay. Let's see. When you use the square root sign in short, include the plus or minus sign. So let's say that we have the area of a circle. Area is equal to pi r squared, and we're required to solve for r. So they tell us solve for r. So to solve for r squared is equal to a over pi, right? And therefore r is equal to plus or minus the square root of a over pi. But r can only be equal to the positive square root of a over pi. And the question is why? Why is that the case? Because we are talking about r. What is r? R is a radius. And since we're talking about a radius, it's a distance. It is a what? A distance. It can only be positive. Let me repeat that. When we are talking about a distance, it can only be positive. There is no such a thing as negative 1 centimeters or negative 10 centimeters. Impossible. So because we are dealing with measurement, right, we're dealing with length, it has to be positive. So let me give you a list of some of the cases where you'll have positive answers. Let's say you have a square root and you need to make the choice. Then if you're solving for something like a unit of length, distance, time, temperature, all have to be positive, right? So let's say if this was time and you had time is equal to plus or minus the square root of something, it can only be the plus solution. It cannot be negative, right? So that's exactly it. So you got your length, distance, time, and temperature, right? And then from length, you can add things like volume, area, perimeter, and so on, whatever the case may be. But what I'm saying is these are the base units now. Not even distance too. These are all the base units. So therefore they cannot be negative. They can only be positive. And get rid of the parentheses so that this exposes any variables. So let's see let's look at an example of that nature. Let's say that we're given 2x into a plus b is equal to 7. And they say solve for a. As it is, we can't solve for a because a is in the bracket. So we need to expose it. So it'll be 2ax plus 2bx is equal to 7. 2ax is equal to 7 minus 2bx. And a is equal to 7 minus 2bx over 2x. Right? You could have also get rid of the parentheses. How can you get rid of the parentheses? By dividing both sides by 2x, right? And then saying a is equal to 7 over 2x minus b, right? That's both will give you the same answer. See if you have to simplify this one here. You have to simplify this one. Watch here. Remember the fraction rule? A plus b over c is equal to a over c plus b over c. Remember that rule? It's the exact same thing here. 7 over 2x minus 2bx over 2x simplifies down to 7 over 2x minus b. Because the 2 and 2 will cancel, the x and the x will cancel. So we're left with this final answer. Very, very simple. So you can see two different approaches gives you the same answer. But the idea is that if you have parentheses, we have to get rid of the parentheses. Either by distributing or dividing by the monomial that's in the front. Or whatever's hindering this variable from being exposed. Understood? Right. Another example could be z equals to ka into x plus y over c. And it says solve for x. Then we multiply by c on both sides. So zc is equal to ka into x plus y. Then I'll divide by ka on both sides. So x plus y is equal to zc over ka. And then I'll say x is equal to zc over ka minus y. And that's how we solve for x. Right, very straightforward. Can you see that? So I need to solve for x, but the x is currently within the bracket. So I need to get rid of the brackets by dividing whatever's in front of the bracket. Right, so that's what that general rule is.